let's attempt this problem right here. We have the cubed root of the radicand 64a squared b to the 5th divided by the cubed root of the radicand 9a to the 4th b squared. Now, there's two ways to approach this one. You could simplify your radicals first, or you could use the quotient rule to write these under the same radical and then attempt to simplify. So either way you approach it is just fine. What I'm going to do is I'm going to write them under a single radical, since they have the same index of 3. Now, I'm going to look at 64 and 9. These numbers have no common factors. I couldn't reduce that. I don't want to do its division just yet. But I notice a squared over a to the 4th. That's something I can simplify. If I use the quotient rule, 2 minus 4, well, that would be a to the negative 2nd. 2 minus 4 is negative 2. Well, a negative exponent just means I'm going to put it in the denominator. And then we have b to the 5th over b squared. Well, I can use the quotient rule there. Since they have the same base, 5 minus 2 is 3. b to the positive 3, we put that in the numerator. So notice by doing that, we're simplifying it to look a little nicer, numerator and denominator. Now I'm going to rewrite it using the quotient rule, the cubed root of the numerator over the cubed root of the denominator. Now, maybe I want to simplify my numerators and denominators as far as I can at this point. Well, the cubed root of 64, I identify 64 as a perfect cube. This is 4 cubed. So I can rewrite it as 4, and the cubed root of 64 being 4, the cubed root of b cubed, well, that's a perfect cube. I can pull that out as well. So I have 4b on my numerator after I've simplified it over the cubed root of 9a squared, which 9 is a perfect square, but not a perfect cube. A squared is a perfect square, but not a perfect cube. So now it's time to rationalize this denominator. Well, to rationalize it, I've just identified 9 as a perfect square. But what I need to get rid of this radical is a perfect cube. Well, I would need one more factor of 3 in order for this to be a perfect cube. 9 times 9 is 2 factors of 3. So I would need one more factor of 3. So I have the cubed root of 3. Well, I have 2 factors of a. I would need one more factor of a to make it a perfect cube. So if I multiply those together, I would have the cubed root of perfect cubes. What I do to the denominator, I have to do to the numerator. So now if I combine this, the cubed root of 9a squared times the cubed root of 3a would be the cubed root of 27a cubed. Now, to save the time, I know I have 3 factors of 3. And I'm taking its cubed root. And I know I have 3 factors of a. So I'd get a when I take its cubed root. Now the top I just multiply. I get 4b cubed root of 3a. This is the simplified version. Now that was a lot of work and a lot of steps. And you could have done different steps at different areas. But hopefully you still come to the same conclusion. 4b cubed root of 3a divided by 3a. This example here, I'm going to leave this for you to attempt. It's the square root of 4a cubed b divided by 3ab squared. All of this is under the radicand. So simplify and then rationalize that denominator. All right, we have a few more examples we're going to look at. Here we have 1 over 2 minus the square root of 3. Now this is different than the other examples that we've seen because it has a sum or a difference in the denominator that contains a radical. So in order to rationalize this denominator, we have to find a way to get any square roots or any radicals out from our denominator. Well, in order to do that with a sum or difference, we have to use a tool that we should be familiar with, and it's called the difference of 2 squares. If we recall, if we have the difference of 2 squares, if I FOIL this out, I get the first term squared minus the second term squared. A times a is a squared. We'd have an inner term of a times b, an outer term of negative a times b. The two middle terms would cancel out when I combine like terms. And the last term, b times negative b, is b squared. So it simplifies to this. Well, the middle term cancels out. That is actually a tool we can use, because these are something that are called conjugates. We have the sum of terms. Its conjugate is the difference of terms. So we're going to use conjugates. And if you want to know how that's spelled, conjugates, C-O-N-J-U-G-A-T-E-S, conjugates. We're going to use that as a tool. That will help me rationalize the denominator. So whenever I see a sum or difference in a denominator containing a radical, I can multiply by its conjugate. So if we look at this, its conjugate is 2 plus the square root of 3. We just change the sign in between them to find its conjugate. Now, just like any fraction, what I do to the denominator, I want to do to the numerator as well. And now we have to multiply it. Because we've already discussed multiplying, this we can treat as a binomial. This we can treat as a binomial. I would have to FOIL that denominator, just like I FOILed this. On the top, I just have to distribute, because this is not a binomial. It's a monomial. It's just a single 1, which makes that multiplication pretty easy. 1 times 2 plus the square root of 3 is 2 plus the square root of 3. But here, when I use FOIL, 2 times 2 is going to give me 4. The middle term is going to be negative 2 square root of 3. The outer term is going to be positive 2 square root of 3. They're going to cancel out. So since they cancel out, I can ignore them. And then I have negative square root of 3 times positive square root of 3 would be negative. A negative times a positive. Square root of 3 squared would be square root of 9, which is 3. We're squaring a square root. It goes away. 4 minus 3 is 1. Now notice we no longer have a radical in our denominator. By using its conjugate, you're going to eliminate that. Now we can simplify it. Well, anything divided by 1 is just that value. So by rationalizing that denominator using its conjugate, we simplified it to 2 plus the square root of 3. There's not even a fraction anymore. Sometimes that'll happen. Very convenient. So that's called using the conjugate. So let's look at another example. This one has 2 square roots in it. Using the conjugate will still work. We have the difference of these terms. So we can multiply by the sum of those terms, its conjugate value. What I do to the bottom, I have to do to the top. And we can see, OK, well, on the bottom, I'm going to have to FOIL. On the top, I only have to distribute. If this was also a binomial, we'd have to FOIL there as well. So I'm going to distribute this. I'm going to get 6 square root of 2 plus 6 square root of 3. Nothing I can really simplify there. When I FOIL the bottom, because it's the difference of squares, I essentially just have to square the first term minus the square of the second term. Well, the first term squared is 2. It gets rid of that square root. The next term would be minus 3. 2 minus 3 is a negative 1. Now, with the last example, is a positive 1. So to simplify it was simple. We got rid of it. But here there's a negative. Essentially, we can't leave a negative in the denominator. If I divide by a negative, it simply changes the sign. So this is negative 6 square root of 2. This would be negative 6 square root of 3. So we've simplified that. No more radical in a denominator. All right, I want you to try this one on your own. Multiply by the conjugate. First of all, determine the conjugate. Multiply denominator and numerator by that value. And simplify and see what you get. All right, let's talk about dividing again. We're going to go back to that a little bit. Dividing is essentially simplifying a radical that might be in the denominator, or it might be in the numerator, or both in some cases. So what we want to do is simplify, factor, and that is part of simplifying, reduce it, and then rationalize our denominator. But sometimes we'll actually be asked to rationalize a numerator. And that can be some applications we might see in calculus if you're progressing to that. It makes the math a little easier sometimes. So rationalize. Let's take a look at one more example here. If we're going to simplify this, well, I'm going to simplify the numerator first. I recognize a factor of 9, so we are factoring. If I recognize that, I know 9's a perfect square. I can pull it out. It would be 3. So I simplified that top one the best I could at this point. Here we have the square root of 2x squared in our denominator. Well, I can simplify that by pulling out an x. So the square root of x squared is just x, because a square cancels a square root and vice versa. So now we've did a little bit of simplifying. I still want to rationalize this denominator, because I can't reduce anything outside of it. Or maybe I can reduce something inside of it. I'm going to use the quotient rule, because both of these are under a square root. I can split it up and have this value. 10 over 2, well, that reduces to 5. So I'd have the square root of 5x. This reduces to 5x. And now I can just put it back together. 3 square root of 5x over x. Now notice my denominator is rationalized, so I don't have to rationalize that denominator. But we may be asked to rationalize the numerator. So how do we do that? Well, let's think of it this way. Well, what did we do when we wanted to rationalize the denominator? We made it a perfect power of that index. Well, we can do the same thing to a numerator as well. So what I'm going to do is say, well, I have a square root of 5x. I would need one more factor of 5 to make it a perfect square, 5 times 5, and one more factor of x. What I do to the top, I want to do to the bottom, because I'm essentially multiplying by 1. And now we're going to be able to rationalize a numerator. 3 times the square root of 5x times the square root of 5x. Well, this would be 5x, because we're squaring that square root. 3 times 5x is going to give me 15x. In the bottom, we have x times this value. It is what it is, x times the square root of 5x. So in this case, we actually rationalized the numerator. So you can go one way or the other, depending on what you're asked to do with that. So this has been section 6.3, working with radicals. Thank you for watching.